Good morning and welcome to Julie on Air. I'm Julie Li Ziwei, the host for today, bringing you the latest update from around the world. Let's start with today's topic, self-driving cars, which is known as autonomous car. It is a vehicle that's capable for operating without human intervention. How do these cars actually work? They rely on sensor, machine learning system, and powerful processor. They can go anywhere just like a traditional car goes and do everything that an experienced human driver does. To help us more understand about the self-driving cars, we are pleased to invite Professor Do-An Tan, Liu Ai Hua, and Kong Yi-wen. They are the experts in robotics and AI from University Science Malaysia. They will lead for the next section.
Good evening, I am Do-An, and welcome to this special edition. Tonight, we dive into how artificial intelligence powers real-world self-driving car. From technology like neural network, SLAM, and natural language processing to what truly makes a vehicle autonomous. We will analyze how AI-driven cars can enhance road safety, accessibility, and efficiency, while also facing challenges like public trust, urban complexity, and technological reliability. Potential concerns include cybersecurity risks, system error, privacy issues, and the broader impact on employment as automation grows. On the ethical front, questions arise over responsibility in accident and the fairness of decision-making by machine. Ultimately, as we push toward a driverless future, how we manage this opportunity and risk will shape not just transportation, but society as well. So, stay tuned for our full coverage.
I'm Liu Ai Hua. Now I would like to explain the example of how AI is being applied in self-driving car. Firstly, artificial neural network processes raw sensor data from cameras, radar, and other sensors. It helps the vehicle to identify, detect, and categorize objects in real time. Artificial neural network also track their movement to predict future locations. For example, Tesla used neural network to process camera data for detecting objects and making driving decisions in autopilot. Besides simultaneous localization and mapping, SLAM is the technique used to map an environment while also tracking their own position within the environment. SLAM uses sensors to gather data and create the real-time map of the environment as the car drives. It helps the vehicle track its exact location within the map, improving navigation precision and decision-making. For example, Waymo uses SLAM to create 3D map of the environment and localize itself on the route. Natural language processing is also one of the examples of AI that being applied in self-driving car. NLP is the field of AI that focuses on enabling machines to understand, interpret, and respond to human language in a way. NLP enables the drivers to interact with the vehicle using spoken command. For instance, Mercedes first used NLP in their MBUX infotainment system, allowing drivers to control the vehicle's function by simply speaking to the car. Next, I will pass on to my friend Miss Yi-wen to explain the impact of self-driving car on the society.
I'm Yi-wen. I'm great to be invited by today's host Ziwei to share about the impact of AI applied to self-driving cars on society. First of all, it must bring benefits. It had reduced road accidents and enhanced public safety. AI in self-driving cars help reduce accidents caused by human error, interactions, and fatigue. For example, AEB and AES as key features can help to detect, analyze, and respond to potential dangers in real time. As of 2025, AEB is mandatory in Japan, the European Union, and also Australia. Besides that, AI-powered self-driving cars enhance mobility with AI's robotaxis. It makes robotaxi service more accessible, convenient, and inclusive, benefiting everyone, including daily commuters, the elderly, disabled, and patients. Example of robotaxi service are Waymo ones in the US and Apollo Go in China. For the future, Tesla plans to launch its robotaxi service in Austin, Texas in June 2025. Besides, while everything has two sides, so each self-driving cars have facing some challenges also. Firstly, is the public trust issue. Based on surveys in the US by AAA and the UK by Fit Alliance, more than 60% and above citizens of both countries are not trust in self-driving cars compared to human-driven car. Well, based on the NHTSA database, self-driving cars have 9.1 crashes per million miles, while human cars have 4.1. The complex driving environments are also one of the challenges. Bad weather conditions such as rain, snow, and flood can make sensors like camera and LiDAR less effective, making it harder for the car to detect objects and make safe decisions. Secondly, traffic signals, violations, and urban complexity. For example, unclear lane markings, busy intersections, unexpected pedestrians or cyclist movement, and obstacles like poor lighting or building shadows. So that's all from me for the social impact. Now I will leave the part of ethical considerations to the journalist Kake.
Hi, I'm Kaki. I just interviewed an office lady, Miss Look. She speak out on ethical considerations of self-driving cars by leading us with their theory problem. Just imagine an unavoidable accident happening. Should the cars prioritize driver safety or minimize danger to others by sacrificing your life? These are not just rhetorical questions and must be programmed into the car's decision-making system. If we drive the car in manual mode, whatever action we take is considered as a reaction, not a deliberate decision. But if the movement taken by the self-driving cars have been instructed by the programmer, it looks like a premeditated homicide. Another consideration was also pointed out by her. As we know, self-driving cars with some features like cameras, GPS, microphone, and so on for gathering information and making decisions on the road. It raises some ethical considerations which are location tracking and sharing effects. Imagine if the third party can access this kind of information. Will the company sell your locations or behavioral data to advertisers or insurers? Will the government request data to monitor you? With these considerations, a sharing effect appears. People will start to change their behaviors if they know that they may be being watched by someone. This is not encourage free expressions and also social interaction. For knowing the potential concerns, let's pass to my colleague Chaim.
I would like to discuss the potential concerns of autonomous vehicles. Firstly, the safety and reliability concerns. One of the primary concerns with autonomous vehicles is the malfunction of automated systems. The system might not be able to identify traffic signs or warn drivers when they are straying from their lane. As a result, when drivers depend too heavily on these systems, they may not notice problems in time to take corrective action, potentially leading to serious accidents. Next, the automated systems struggle to anticipate behavior of pedestrians and animals. We notice that current automated driving systems may be ineffective at identifying humans or animals on the road, predicting their next movements, and responding to avoid collisions. Another significant risk involves the cybersecurity vulnerabilities. Because of autonomous vehicles rely on complex data communications, making them vulnerable to cyber attacks. Hackers could manipulate the vehicle's AI systems or operating systems, such as steering and brakes, which lead to dangerous situations on the road. Alongside safety concerns, the widespread adoption of autonomous vehicles also brings to the workforce effects. The most immediate effect is direct job displacement. There is quite a high risk of unemployment in sectors that rely on human drivers. Occupations such as truck, taxi, delivery, and bus operators are particularly exposed. In addition, the employment trends and income inequality. The transition to autonomous vehicles could contribute to income inequality if lower skilled workers cannot access new employment opportunities or retraining. Last but not least, changing job requirements and skills. Employees will need to adapt to new digital or technical skills. For example, the skills of programming, robotics maintenance, AI oversight, and so on. Now, I will hand it over to Kiara, who is an expert on autonomous vehicles.
To sum up, AI is transforming the way we think about driving. It powers self-driving cars through technologies such as artificial neural networks and reinforcement learning, helping reduce accidents and improve mobility for everyone through robotaxis. Despite the benefits, there are still big challenges. Public trust is low and the technology isn't perfect, especially in bad weather or complex environments such as busy cities. And there are ethical concerns around data privacy, decision-making which is related to safety and job loss. What stands out the most to me is that AI in self-driving cars goes beyond just technology. It's about the impact it has on people. The way we design, regulate, and use it will determine if it drives real progress or if it creates bigger problems such as job loss, privacy issues, and so on. It's up to us to make sure this innovation truly moves society forward. At the end of the day, AI is powerful, but it's our responsibility to make sure it's used wisely, fairly, and for the good of everyone.